Okay. I'm not really set up, but I knew I was running late. So I wanted to at least get on here and show my face. Even if I don't show my face. Even if I don't cover a lot of material today, if any material today. But because I don't even have my tripod set up, nothing. I don't have nothing set up. So you all have to, if I don't wait on me and show my face. Even if I don't cover a lot of material today, if any material today. But because I don't even have my tripod set up, nothing. I don't have nothing set up. So you all have to, if I don't wait on me and show my face. Even if I don't cover a lot of material today, if any material today. But because I don't have. So yeah, here I am. I'm setting my tripod up right now. If you have any questions, please ask. That's going to make this way more interesting than me just, spouting off a whole lot of information that nobody may even be interested in. But if you have any roofing questions, just let me know. You have any projects coming up, let me know. If you have some blueprints you want me to look at with you, let me know. And I can give you some tips and pointers. I'm setting up my tripod right now. I got a lot going on here. Let's see. Okay. Take it up a little bit more. All right. I guess I could show you another one. Yeah, this one is better. I don't know if you could see it because it's written in pencil. But you can see I want you to focus on this right here. I want you to focus on that right there. That right there. You see that little square there? Focus on that. If you look real carefully, you can see there's a diagonal line running through here. That diagonal line represents I'm zooming it up a little bit more. That diagonal line represents the hip right there. It represents the hip. You see how it's not hitting the corner of the building? This right here actually represents the subfascia. Okay. This right here represents this 90-degree line. These 90-degree lines represent the building line. Okay. So you got 90 degrees represent the building line. And then you can see that this line, I got a dotted line here. That represents an inside corner where a valley would go. Okay. And this dotted line, 90-degree dotted line, represents the same thing. You see, it's a dotted line here, and it's a dotted line here. It's a 90-degree dotted line, which represents the outside of the subfascia. You see that? So last week we went through this whole thing, and we showed all these measurements here. Okay. We showed the common, 712 common, the 1112 common, and we showed the 8 and 8.353, which is basically 8 3/8, 16 hip valley. Okay. So we got our 3 pitches, the 712, the 1112, and the 8 3/8, 17 or 16.97. Okay. So this hip, you could see here, and you could see some of the measurements that I've wrote down is 57.53 degrees. And this is 32.46 degrees on the 1212 side. A good rule of thumb is the angle that has the steepest angle, and in this case is the 57.53 degrees. Now, you know, that's very, very exact for what we're doing. Okay. But, you know, if you got a 60-degree saw, I don't think there would be anything wrong with just putting it on 60 and 30, you know, 60, 30. And that will be close enough for framing, for rough framing. You see? So yeah, 37.53 degrees and 37.53 degrees for the 712 side. That's the bevel that's going to be on those rafters. And on the 1212 side, it's going to be 32.46 degrees, 57.53 degrees on the 712 side. This is the 712 side here. This is the 712 side. The rafters are going to be going just like this. Okay. The 1212 side, the 1112 side, the rafter is going to be going like this with a 32-degree bevel. You say, hey, baby, how you doing? Yeah. So what I could do this evening, quickly, briefly, is I could show you how to draw this up. I could do a big version of this, because on this sheet of paper, I just have it drawn right in the corner, but I could do a bigger version of this. And I think that's what I'm going to do. So I'm gonna get a blank sheet, find a blank sheet of paper, and we're going to draw that. We're going to draw that out. Okay. All right. Get your first 90-degree corner. I'm doing this with a pen so you all be able to see it very clearly what I'm doing. Okay, so we got a 90-degree corner. This is the building line. A 90-degree building line. Okay. Now what we're going to do is we're going to extend this line out, dot it. And we're going to extend this line out, dot it. You see that dotted? Now, this dotted line here represents the building line for inside corner. The solid line represents the 90-degree for an outside corner. The reason why I draw it this way is so you don't get the valley lines mixed up with the hip line. The hip line is going to be the lines that cross over the 90-degree inside corner, outside corner. And this is the inside corner. Now we're going to draw the subfascia.
No. But I don't know. But no, if he wasn't that happy, then he was gonna catch it. Yeah, that's the whole thing. Everything else, it's not on for me. What? Yeah, that's the whole part for me. But yeah, El Cheapo. El Cheapo. Yeah,
So you can see exactly how I drew this. Okay. This is the 90-degree for an inside corner for the building line. This is the 90-degree for an inside corner or outside corner for a subfascia. Okay. This is the 90-degree corner for an inside corner for a valley. This is the 90-degree corner for the inside of the subfascia corner. You see? So this is the subfascia. This is the building line for a inside corner. Outside corner, in other words, a corner pointing out away from the inside of the house, that's 90 degrees, and the outside of the subfascia is 90 degrees. You see? This is a very beautiful way of drawing valleys and hips. Now watch this. Now I already know that my hip is going to swing towards my steepest side, and the steepest side is going to be this side. So all I do, I don't have it go straight to the corner because that'd be 45 degrees, but I have it go offset. And I just any wild place, it don't matter, as long as it's offset. You see that? It's offset. That's an offset hip. All right. That's the beauty about this. Now, let me show you this. The theory, and this is what a lot of guys don't get, the theory. Because of how I drew the inside and outside corner adjacent to each other. Because of the way I've done that, you can see where you can estimate or calculate where the hip is going to hit for the valley, which is this mark, and you can see where it's going to hit for the hip. So the hip of the rafter is going to be hitting here on the building line. But for the valley, the building line is this on an inside corner. You see that? That's the beauty of this. You could do this on a job site. You can do it on a sheet of paper. You could do it on a sheet of plywood to scale. That's what's so beautiful about this. So we're going to take some of the measurements that we do have, and we're going to plug them in to this. Okay, so we're going to take some of the measurements that's on this chart here, and we're going to plug it in to this larger one here, so you can see exactly what's happening. All right. So now, by looking at our chart here, we can see that the hip comes off the corner 1.144 inches. 1.144 feet. Sorry. So I'm gonna put my calculator here. Hopefully you can see the numbers pretty good.
But a lot of stuff they get from African culture.
Okay. So I want to make sure you all can see my calculator pretty good. I'm going to tilt this up just a little bit. That's better. Okay, so you can see that we have 1.144. So we're going to put that in the calculator. 1.144. Okay. We're going to plug that in to here. We know that from the corner here is 1.144 feet. So we're going to write that here. 1.144 feet. We're going to change that feet into inches by dividing it by 12. I'm sorry, by multiplying it by 12. 1.144 times 12. 13.72 inches, which is basically 13 3/4. So we got 13.728 inches. Okay. The inches and feet, same measurement. One is just in feet, one is just in inches. Okay. Now what we do to figure out how far you measure off the corner of the building, for an inside corner to get the valley measurement. What you do is this. You come over here on this chart. You see that 3.009? You put that in your calculator. 3.090. And what you do is you divide this number, 3.090, you divide it by 4.865. Divided by 4.865. And you should get this number here. 1 point equals. No, you don't get that number. The number is that you get is 0.635. I don't know if y'all can see that. It's 0.635. Okay, not this number like I was pointing to. Not this number like I was pointing to, which is 1.571. And so now you take this number and you multiply it times 1.1, 1.1, that 1.144, 0.144 equals. Okay. Melchizedek. Is he coming? Okay, give me that cup of ice in there. It's a cup of ice in there I left. On that joint compound. Go in there and see if you get see that calculator. Whose is this?
I thought that was yours.
It's not mine. It's somebody else's. I can't drink this. It's one of these in there. Just bear with me for a moment. Okay, thank you. Okay, this one, I'm gonna have to retire that one. Okay, 1.144. Okay, now we're gonna store that into the calculator. We're gonna store that into the calculator. Clear it. Okay, so 3.0. 3.090. Divided by 4.856 equals times recall 1, which is 1.144 equals, okay, 72.7. Okay, so this one is 72.7.727 feet. Now what we do is we take this and multiply it times 12 to see how many inches it is. And it's 8.735 inches. 8.735 inches. Okay. So now we know from here, from this corner to this corner, is 13.728. which is 13 and 3/4. And from here to here on the valley is going to be 8.75, 8.735 inches, right to the center of the hip, not to the side of the hip, the center of the hip. So the center of a hip, if it's an inch and a half wide, is going to be 3/4 of an inch. If it's a micro lamb, it's going to be 7/8 of an inch to the center of the hip. So you're always measuring this line here. Always, this line right here represents the very center of the hip. I don't care how wide is. It's wide hip beam. That means it's going to be 3 inches to the center. So it's center. This line always represents the center. Everything is a center. That's how you're going to know exactly where to put your hip on your exterior corner, your corner that points out from the house. Oh, thank you, baby. And your interior corner that the valley sits on. You're going to know exactly where that fits. You ain't going to have to guess. You ain't going to have to worry about your plywood being all a big gap being at the end of your hip, or your hip being too high and all that kind of goofy stuff. Those are novice mistakes that a lot of so-called professional carpenters make because they never learned the stuff that I'm talking to you about right now.
Because I think this entity plays a part in bringing on the vengeance of those who gotta get their time. So is he opposite of Christ? Yeah, I guess he is. You don't have to fall into his hands.
Let me show you something else about the hip and valley, okay? For any roof, any mixed pitch roof. Now, you already know that from here to here is 13 and 3/4 to the center of the hip. You already know that. So let me see something here. Let's say that this right here is a 2-foot overhang on each side. 2-foot overhang here and a 2-foot overhang here. 24 inches plus 13 and 3/4. So what we do is 13.725 plus 24 inches, which is this right here. Let me write that in so you can see exactly what I'm talking about. I'm gonna make some brackets in here.
The devil is inside. These are two different things we talk about.
So this is 24 inches here, and from here to here is 20. From here to here is 24 inches. All right. Now, we know that from here that's 13 and 7/8 from the corner of the building to where the hip is. 13 3/4. So we got 13 and 3/4 plus 24 equals. So from here to here is 37.725. That's 37.728 plus 24 equals 37.725. Okay. Now, you know from here to here is 24 inches. So what we're going to do is divide 37.725. We're going to divide that by 24 equals 1.571, which is the same measurement we have here, the same secant that we have right here, 1.1571. Okay, so that lets us know that all our angles are on point. Now what you can do is turn this measurement, this secant measurement, you could turn this into degrees. How do you do that? Simply by pressing the second function on the calculator and then tan. And you can see it's 57.53. So we know the steepest pitch, the steepest angle is going to go on the shallowest pitch side, which is the 712 side. So we're going to put this here. 57.53 degrees. Okay. Now, let's see. We're going to store this, and we're going to subtract 57 from 90, so we can get our other degree pitch, which is 32.46. So that means this side, the bevel on the rafters is going to be 32.46 degrees. Okay, 32.46 plus 57.53 is 90 degrees. Okay, that's how you know these two are right. They have to add up to 90 degrees, or real close to 90 degrees. 89 degrees, 90 degrees, close enough. So we got our degrees for our bevel for both sides of the rule, for the 1112 side and for the 712 side. Okay, that's how you get that. Now I'm going to recall the degrees here, which is 57.53 degrees. And now what I'm going to do is I'm going to press cosine. Then I'm going to press this digit here, which I don't know the name of it. 1 power, I guess. I'm going to press that. Okay. Then what I'm going to do is we know that this is 24 inches, but what I want to do is we know that our subfascia is 1.5 inches wide. Okay. So what we want to do is cut 1.5 inches off, subtract 1.5 inches from 24 inches, and that's going to give us 22.5. The 22.5, you take that, and you multiply it times this number, 22.5 equals, which is 41.91. Now I'm going to show you what this 41. I'm going to show you what this 41.91 is. What is this 41.91? Hold on a second. Now I lost my pencil that quick. Okay, we're going to draw a little triangle here. The 41.91 is the measurement of the actual run for the hip, not the run for the valley now, but the run for the hip. We're going to figure the hip out, the valley out later on. But this is the run for the hip, 1.5 inches short. Okay. And so that measurement is 41.91. So we put 41.91.7. We put that in. Okay. We take this number, 41.97 is already in the computer, and we divide it by 16.97, which is the step off for hips and valley, equals 2.470. So that means that there are 2.470 step offs in 16.97 increments for the tail of the hip. So what we do is we take that 2.47 and we multiply it by 18.91, which is the step off, the rake step off for the hip roof. So we're going to put 2.47 times 18.91, which is 46.70. 79. Okay. 46.79. Okay. That's how long your rafter length is going to be for your tail on your hip. Now, so you might ask, well, what is the measurement for the valley? I'm going to show you how to do that. For your valley, we already know from its inside corner to the center of the valley is 8.735 inches. We're going to put that in our calculator. 8.735. Okay. Now, we know that this is 24 inches here. From here to here is 24 inches, just like from here to here is 24 inches. Okay. We know that's 24 inches, but we got to subtract we have to subtract 8.735 from 24. So we just said minus 24 equals. We can get rid of that minus sign. 15.265. So that means from here to here is 15.26, which is basically 15.25. So we're going to put a little bracket here. We're going to write a little bracket here and label it. And this is 15.265. 15.265. Okay. That's from the center of the valley all the way to the outside of the subfascia. Now, to find the degrees for this, you do the same thing. 15.562, and you divide it by 24 equals 6363. 636. Okay, 0.636 feet. Okay, that's your secant. So we go second, tan, And see, we got our 32, 45, or same thing, 32, 46, same thing. Okay. Then what you do is you cosine, then you press this one power sign, and you multiply this number that you get after you press that one power sign. You multiply that by 22 times, times 22.5. Why 22.5? Because an inch and a half from 24 inches is 22 and a half. And then you press equal. Okay, I messed up something. Let's do it over. 15.265 divided by 24 equals, okay, we got second, tan, okay, 32 is that, cosine, first power, times 22.5 equals, okay, 2666, which is 26 and 5/8. So this right here is for the hip. That's for the hip. And this triangle is representing for the valley. Okay. The run, the run, the run for the valley, tail hangover, the valley tail for the rafter is 26.665. Okay, basically 26 and 5/8. All right, we take that 26.665 and we divide it by 16.97 equals 1.571 times let's see. That's interesting. Let me do that again. 26.665 divided by 16.97 equals. Oh, that's really interesting. Okay, so we know that the is 1.57 step off for the valley. And we multiply that times 18.91 times 18.91 equals 29.71.3. So 29.71.3 inches. That is the measurement for the valley tail measurement on the rake. Okay, so that's basically, that's how you do it. When you know this method, it's no way you can mess a hip up. It's really no way. It's no way that your plywood is going to be sticking up at the corner of the subfascia. It's no way it's going to happen. Now, I'm not on the job site and I don't have a piece of wood in front of me to show you how to actually cut the hip and cut these angles in. But you know, I'm going to try to do that sometime this winter, get around to doing that. But how to make tails, make perfect tails. But anyway, I just came on today. I'm going to do this every Monday, 6:30. It's my targeted time for being on here. I came on a little late tonight, but 6:30 is when I'm going to try to come on here. And I want you all to take it easy. Be careful with your equipment. And I'll see you next Monday. Shalom and peace.